Hello students and welcome to the next module of reflection of sound from curved surface. Students, we all know that light is reflected from curved surface. Similarly students, sound is reflected too. Both of them obey the same laws when it comes to reflection from the curved surface. Now students, let us consider a given arrangement to completely analyze the reflection of sound from the curved surface. So our arrangement initially would consist of M1 and M2, which are two large concave mirrors facing each other. So I'll help you imagine it. M1 and M2 you can clearly see are facing each other and they also share a common axis. Now further, F1 and F2 are the two coaxial foci respectively. Students, foci or focus is the point where all the waves reflected from either of the mirrors are going to be focused. So here we have two focus points, that is nothing but F1 and F2. Students, a watch is placed at focus 1. That means there will be a ticking sound, right? And this particular ticking sound will give out sound waves, and these sound waves will have chances of getting reflected from the closest mirror, which is nothing but our mirror M1. Now students, let us go ahead. A funnel is placed at F2 such that we can hear the sound via the funnel. Which sound? Obviously students, the sound of the ticking clock. This sound is going to get reflected from the mirror M1, then come to M2 and then get focused on the focus point F2, and then we'll hear the sound. But students, what happens is, if the funnel is moved to and fro, as you can observe, if it is moved to and fro, the maximum sound is heard only when the given funnel is at F2. Now students, this should have some reason. How come all the waves that are reflected from M1 and are again reflected from M2 and focused on point F2 are heard maximum only at F2? Why does this happen? So students, the answer to your question is in the flow of the waves. Let us consider the first flow of the wave. First of all, what happens? Sound waves starting from watch F1 are reflected from M1. Exactly as you can see in the diagram, we have sound waves from the clock are getting reflected from M1. Now what happens ahead? These sound waves are not going to stop there itself, right? These are going to propagate ahead. Now what happens ahead? These reflected waves travel parallel to the axis and fall on M2. Now once they have fallen on M2 students, what happens next? Next, M2 focuses these waves on F2, thus leading to maximum sound at F2 students. So if you see this particular reflection pattern, very clearly you can see that the maximum sound can be heard only at F2. So here we say that sound gets reflected from surfaces. Students, we have learned two types of wave, transverse wave and longitudinal wave. In the upcoming modules, what we'll be doing is, we are going to study the reflection of transverse wave and longitudinal wave as well. From which medium? We are also going to have two types of medium students. That is the rarer medium and the denser medium. The knowledge of reflection will help us to understand many concepts, not only in wave motion, but even in other topics of physics. Thank you students, and I will definitely see you for the next module. Thank you.